Okay. All right. So we're going to cover two sections today. We're going to cover sections 2.4 and 2.5. Now, I do apologize. I am left-handed, so I'm going to be writing over the top. So you're going to see my hand, and then I'm going to move out of the way, and then I can talk about stuff. So I'll try not to explain while I'm writing, but you've also got to deal with my terrible handwriting. I'm a dude. I'm left-handed. I kind of write like a doctor. So if you can't read something, or if you need a way to interpret my Egyptian hieroglyphics, just let me know. I do my best to kind of write neatly, but sometimes it goes well, sometimes it doesn't. Anyway, 2.4, we are going to solve and graph and give interval notation for linear, one variable inequalities. Okay, so this is an algebra course. It is based off of all the algebra that you should have learned back in high school or early on in previous courses or whatever. So, quick backtrack. Algebra is all about equation solving and solving for x. So an equation will have an equal sign. Typically, a one variable equation will have one solution. Okay, for example, if they told you to solve 3x plus 2 equals 8, we could solve that for x. So just real quick, I'm going to go through this to solve for x. You want to get the x part by itself. To get rid of all this stuff, you're always going to do the opposite. Whatever you do to one side of the equation, you got to do to the other. So if I want to get x by itself, I want to get rid of the 2. Opposite of adding is to subtract. 2 and 6. If I want to get rid of the 3, the opposite of multiplying is to divide. X is 2. That's an equation. Okay. One variable equation, one solution. Now, they did get fairly complicated with equations. Whenever you start solving these, they start throwing in parentheses. They start throwing in fractions. They throw x's all over the place. Okay. They can make these equations relatively difficult, but by and large, the whole point is to simplify. Okay. Let's see. I think there's a way to lock this screen. Anyway. So anyway, if it doesn't make all these, should be able to stay on my screen. Anyway, the screen popped off and then it came back. Anyway, like I said, an equation, typically one variable equation, one solution. Now there were ones where there were no solution or infinite solutions, yada, yada, yada. But we're going to focus on a thing called inequalities. Inequalities are different than equations. Inequalities, you will have a less than or a greater than, a less than or equal to, or a greater than or equal to. Okay, we're solving for things that are less than or greater than, okay, more than, bigger than, smaller than, okay? An inequality will not have one solution, but whenever you solve, you're going to find a solution set. Okay, so we're going to be talking about an entire set of numbers. With that solution set, there are 3 ways you can show that solution. You're going to be asked to do all 3. So for example, if, I just start out, we're not going to solve anything, but if I just started out with x is greater than 3, okay, this is the inequality notation. My math lab will actually write it like this, a little bit like a squiggly bracket, another X and a bar and a bracket here. This says the set of X's such that X is greater than 3, okay? This extra stuff here is just called set notation. It doesn't really mean anything other than it's a fancy way to write a math solution. Okay, the important part is the x is greater than 3 here. Okay, so if x is greater than 3, that's the part that we need to focus on. But again, this is called your set notation. Okay, so you should be able to write it as an inequality. From there, you should also be able to graph your solution. So if your solution is x is greater than 3, as a graph, we can show that as well. The way that works is, okay, we've got a number line. The way number lines work, everything to the left is really small. Everything to the right is really big. So as you progress from left to right, you go from small to big. So if I put my number 3 here in the middle, and that shows that 2 would be over here, 1, 0, negative numbers. Okay, bigger than 3, so 4, 5, 4.5, whatever. Okay, so that's how a number line works. To show x is greater than 3, okay, we're talking about all of these numbers that are to the right of or greater than 3. So whenever you graph that, you're going to shade in one direction or the other. Less than, smaller, goes to the left. Greater than, bigger, goes to the right. Okay, so everything bigger than 3 is all of these numbers over here. So we shade that. Now, what's also important is what is happening specifically at the 3. So if it is just a greater than or less than, we do not include the 3, but we want to get right up next to it. So like 3.00001, 3 and 1 a billion. Okay, just slightly bigger than 3, but not quite 3. To show that, we use a rounded parentheses. Okay, so if you see a less than or a greater than, in terms of graphing, you're going to use a rounded parentheses. That does not include the number. It gets right up next to it, but does not include. If you do want it to include the number, like less than or equal to or greater than or equal to, you're going to use a squared off bracket. The next example I do will have a less than or equal to or greater than or equal to, and I'll show you how to do it with the brackets. But when it's not, if it's just less than or greater than, we use a rounded parentheses. And then we will shade one way or the other. The third notation is called interval notation. Interval notation kind of reads basically just like the graph. What is going on? If it ends my thing, that's going to be really problematic because I need to be talking for a while. I just got an indication that said my Zoom meeting is going to end. So if something happens, I will do my best to fix that. But anyway, so interval notation, again, reads from something to something. It reads just like the graph. So my smallest possible solution here is 3. So it's going to read from 3 to whatever. In this case, we're going to go forever big. In math, to say forever, we use infinity. So the interval is from 3 to infinity. So that's your interval notation. Now, outside of that, we're going to use our grouping symbols. And the good news is it behaves just like your parentheses and your brackets from before. So 3, we don't want to include because it's just a greater than. So we're going to use parentheses. Infinity, we can't include. So infinity always gets parentheses. So that's what the interval notation for that would look like. Your book has a ton of examples on this kind of stuff, but that's one example. So if x is greater than 3, this is what the graph of that would look like. This is what the interval notation of that would look like. Okay, I'm going to do another example. Basically with a greater than or equal to. So if we said x is less than or equal to, say, -5. Okay, again, that's your inequality notation. If we write it like that, that's your set notation. So x is less than or equal to -5. Again, the graph. We're interested in what is happening at -5. If we're talking about all of the numbers less than, that would be everything smaller or over here to the left. Okay, so in this case, we are shading left of the -5. Okay, less than or equal to, we do want to include the number. So we are going to have a squared off bracket. So greater than, less than, we use rounded parentheses. Greater than, equal to, less than, equal to, we use that squared off bracket because we want to include the number. Okay, similar interval notation. We're going to read from forever small. Okay, we say that is negative infinity. So forever big goes to positive infinity. Forever small goes to negative infinity. So we go from negative infinity to -5. Now that -5 is included, so it gets the squared off bracket. So again, less than equal to squared off bracket. But again, infinity we can't ever include. It's just a concept. You can't ever get to infinity. So infinity always gets parentheses. So this is basically just an example of what your answers are going to look like. So again, this is your set notation. This is your graph. Okay. And then this is your interval. That's 3 different notations. My math lab asks you to do all 3. Most problems, I'm going to ask for all 3, or at least one or the other. Anyway, make sure you understand which is which, how to do all of those. Now, typically, they're not just going to give you the answer and be like, hey, how can we draw this? Okay, they're going to make you actually solve something. Now, some problems start off relatively easily. Some start out a little more complicated. One thing they may do, so if we had 2x minus 4 is greater than or equal to x minus 5. Okay, it's going to say solve or solve and graph or solve and graph and give interval notation. You should be able to do all those things. We're going to do all of that. So in order to solve, okay, again, we want to get our variable by itself on one side. We want to figure how it relates to our solution and figure out what our solution set is. So again, to do that, I want to combine like terms. I want to get my x's on the same side. So we're always doing the opposite. If I want to get my x over here, the opposite of this positive x is to subtract. Okay, 2x minus 1x, 1x. Okay, I got my -4 here. If I want to get rid of this -4, I'm going to add -5 plus a +4 is -1. So I get x is greater than or equal to -1. So again, that's my interval, or not my interval, sorry, that's my inequality notation. That's my solution set. X is greater than or equal to -1. From there, that's when I would do my same thing. I'm either going to graph it or give interval notation or both, depending on what it's asking for. Okay. If it wants the graph, we're interested in what's happening at -1. We want to shade everything greater than. So that's everything over here to the right. At -1, we do want to include it. That's what, again, this bar means, greater than or equal to. So if we want to include it, we're going to use that squared off bracket. Again, interval notation follows right along with that. So we want to read from -1 included to infinity. So again, here's your inequality. Here's your graph. Here's your interval. And that's basically what this homework is going to be. It's a lot of different solving of problems. The good news is solving behaves just like it did for equations, which you learned a long time ago. There is one, I don't want to say trick, but there's one kind of thing you need to be aware of, pay attention to, watch out for. If say we have something like this, so -2x plus 5 less than -7. Okay, again, fairly simple problem. Get rid of our 5. -7 and -5 makes a -12. If you divide by a negative, or if you multiply both sides by a negative, so not add or subtract, so adding or subtracting a -5, okay, doesn't do anything. But if you multiply or divide by a negative number, your inequality sign will flip. So we go from less than to greater than. So anytime you multiply or divide both sides by a negative number, okay, again, your inequality symbol will flip. It flips from less than to greater than. It flips from greater than equal to less than or equal to. Okay, then if we do the math, negative 12 divided by negative 2, that's a positive 6. So then this is my solution set. That x is greater than 6. So again, on a number line, we would shade everything greater than 6. Again, rounded parentheses because it is not included. Interval notation says from 6 to infinity. Again, not included. And again, my Zoom meeting is counting down like it's going to kick me out. If it kicks me out, I will do my best to get back on. If something happens, I'll keep going. I'll keep this recording. I'll make sure it gets uploaded to the site. I don't know why it's counting me down. I don't know why they gave me a non-professional version of Zoom. This is so frustrating. I hate when crap doesn't work. Anyway, like I said, some of the inequalities get a little complicated. They start throwing in multiple sets of parentheses. They start throwing in fractions. So I just want to work through, I'm not going to show all of the interval notation stuff, but I just want to work through a couple of problems where we have to solve some of the more difficult problems just for fun. So if they threw in something like this. Okay, x plus 3 over 5 minus 1 plus x over 8 is greater than or equal to 1/10. Anytime you're dealing with a problem with fractions, okay, it's relatively difficult, but we want to get rid of our fractions. The way we're going to do this, if we multiply everything by our lowest common denominator,